Kirkham. Hello and welcome back to Module 5. We're going to take a look at the lesson for Day 5, which talks all about distributive property. In this lesson, we're going to make sure that we can use distributive property to make equivalent expressions, and we're going to kind of understand what distributive property is. All right, this first question is kind of a warm-up question to kind of get us thinking about distributive property. You may have seen it in elementary school with numbers, where they may have had you do something like this and kind of showed you that 2 times 3 plus 2 times 4 is the same thing as 2 times 3 plus 4 in a group. So you would have done it with numbers. And the new thing we're doing in 6th grade is we're going to add those letters in there. So here we have Miguel, who has an expression that he's simplified, 6 times the quantity, 3 plus 9. We have Elise, who has an expression she simplified, 6 times 3 plus 6 times 9. And we have Francis, who has an expression that they've simplified with the variable x, so 6 times x plus 6 times 9. And what we want to know is, will Francis's solution be the same as Miguel's and Elise's if x is 3? So we would just replace all of the x's with a 3 and then see if it would equal the same as Miguel and Elise. And if you do that, you should notice that Elise and Francis, their expressions would be identical, because if I replace x with 3, I'm going to get 6 times 3, which is 18. The 6 times 9 is the same, and so I'm going to get 72, because this here would be 18, and I would end up getting 72. So yes, Francis would have an equivalent expression. So now let's take a look at what distributive property is. So distributive property is the format of something times a quantity of something plus or minus something. Okay, so this is this format that you're going to be looking for. And when you see a number directly outside of the parentheses with an expression inside, then you know that that means to distribute, which in this case is multiply. The distributive property allows us to multiply each term outside the parentheses by the number or terms or numbers inside the parentheses. Algebraically, we would say A times B plus A times C. So I usually use these little arrows so that I know I am distributing, whoopsie, this is A times B plus A times C, so that I know that I'm distributing or multiplying to both terms. That is the key here. The biggest mistake people make is that they'll multiply the first two terms and then leave the other term alone. But I like to think of distributing kind of like you're distributing Valentines or you're distributing gifts. If you're walking around and you're distributing something, that means that you're giving them out equally, meaning everyone is getting one. So that's why I have those double arrows up here, because I'm going to be doing A times B and A times C. Whatever number B is, we're going to multiply times A, and whatever number C is, we're going to multiply times A. Okay, then we keep that symbol in the middle the same. So if I'm multiplying here in this expression, I'm still going to get A times B, but this time I'm going to subtract A times C, because the little, whatever expression's in the middle here, you're going to keep it the same. Eventually, if your outer number is a negative, out here, if it's like that, then your inner sign might change, but that'll be 7th grade for you guys. So we're going to focus on just positives on the outside, and therefore our signs in the middle stay the same. So you do just kind of want to be careful with your signs when you're multiplying, and you want to pay attention to if it's an addition sign or a subtraction sign in the middle. Yeah. Okay, so let's do an example of this. We have each of the 4 members of the Robinson family ordered a drink, which is D, 2 slices of pizza, P, and an ice cream cone C. So here we have grouped their order times 4 people in the family. Okay, and what we're going to do in order to find the total amount is we're going to distribute or multiply this 4 by each of the terms inside my parentheses. Now this one has 3 terms. I know that this is its own term because it is between the addition or subtraction signs. 2 pieces of pizza is its own term, and then the cone is its own term. Now, if I write this algebraically, it would be 4 times the drink plus the 2 pieces of pizza plus the cone. And that is going to be, so now I can distribute 4 times D, 4 times 2P, 4 times C. So my expression in the end is going to be 4D for 4 drinks plus 8 pieces of pizza. I'm going to multiply my coefficient by the term outside plus 4 times C. And all of these are pluses because of these addition signs right here. That's why we're going to keep these additions right here. But that right there, this expression and this expression are equivalent. Okay, that is the distributive property. So let's take a look again at another model. So area models we love to use. They're going to be used on SBAC because it is a real life situation, right? If I want to find the area of a rectangle, area is length times width or base times height. I'm basically taking the side times the top. Now, if I want to find the area of the entire rectangle, okay, I would find the area of the length of 5 times the 3x plus the 2x, because I would need this entire side. So I would put inside 3x plus 2. Okay, but I'm not done there. If I distribute this out, if I find the area of just one rectangle, I could add it to the area of the other square or rectangle. It's going to be a rectangle because it's 5 and 2. So 5 times 3x makes 15x. Or, really what I should write is 5 times 3x. And then I'm going to do 5 times 2 to get the area of this rectangle. So my new expression is going to be 5 times 3x plus 5 times 2. And then if I simplify both of those, I'm going to get 15x for the one rectangle plus 5 times 2 is 10. And that is going to be my final expression. That is the area of the big green, the extra large rectangle there. All right. Now over here, this is a little different. So it has a negative here, but in our state, we have not learned positive and negatives yet. So we are going to just pretend that this is a positive and that this is really subtracting between the two. Okay, we're going to pretend that's a subtraction. So again, I could do 7 times the entire thing, x minus 9, or I can do 7 times x minus 7 times 9. And that's going to simplify to 7x minus 7 times 9, which is 63. And that is going to be the area of this guy right here. So if I was doing it individually, it would be minus 7 times 9. In that little box right there. So now we've kind of visualized it with pictographs. We've visualized it with area formulas. And now we're going to just practice distributing by writing the expanded form and then the simplified form. So I'm going to do one for you. I'm going to do number 5. And then you go ahead and do 3, 4, and 6. Pause the video and do those. And then you can come and join me and see your answers. So I'm going to distribute 8 times 7 and 8 times G. So that's 8 times 7 minus 8 times g. Then down here, I'm going to do 8 times 7, which is 53, minus 8 times g, which is 88g. So now you try. All right, and here are our other answers. So you end up with 2x plus 12, 35 plus 7p, and 12r take away 108. All right, so now you have a couple more practice questions. So go ahead and pause the video and do 7, 8, and 9. Same thing we just did. I would definitely practice expanding and then simplifying. And then number 10 is asking us, somebody did their problem wrong. So Mrs. Wenzel asked people to do the problem on the board. And, Miss Wenzel did problems on the board. She asked her students to identify which one was incorrect. So circle the one that's incorrect and fix it. Okay. All right, so here we've got 15x plus 50, 3x plus 12, and 72 take away 24. So as long as you're distributing and multiplying by both terms inside the parentheses, by the term outside the parentheses, you're good to go. In Ms. Wetzel's situation, the last problem was incorrect because this person did not distribute evenly. They multiplied 7 times 9 and got 63, but they forgot to multiply 7 times 8. Oops, and that's 56. I think maybe I did that wrong in a different problem too. 56. I'll get it. All right, so 56K is what it should have been. 63 take away 56. All right, we have a couple minutes, so we're going to do a little bonus problem here. And the question is, which of the following has two equivalent expressions, meaning which has where the top matches the bottom. So in this problem, I've got 12 plus x times 3. And then I have 12 plus x times 3. This one, you should know, is not equivalent because in its addition and multiplication, I can't change those. They have to either be all addition or all multiplication in order to regroup and use the associative property. Here, I've got 12 times x plus 3 times x. So that's going to be, if I distribute 12 times x plus 3 times x, I would need to do 12 times x plus 12 times 3. So that is not correct. Here, I would need to do 12 times x plus 12 times 3. We've got this part, but whoopsies, we're missing here, so that one's not right. So D better be right, or else I did something wrong. 12 times x plus 12 times 3. 12 times x plus 12 times 3. We have a winner. All right, and that, my friends, is distributive property. So keep practicing, head back, make sure you pause, check out what I did, and if you have any questions, ask me in class. Bye.